So our TARC 2022 design was modeled in open rocket, and that was because it's just for free. It's the least expensive way of modeling for people that don't have a whole lot of money. And the primary goal is, again, to make an estimate so you can get initial motor sizes. And there's some design criteria and decisions that you should make. The TARC 2022 is going to require boosting 2 eggs this time. The unique feature is that they have to lay horizontal to the model, and that requires a special payload compartment foam that you can purchase from Apogee Components. Make sure you don't get the vertical one because that's for the S4 type international competitions now. TARC has a horizontal requirement, and it's a very special foam egg compartment. So you might as well just go ahead and make that purchase as soon as you can. Then the other issue is the model has to have 2 different tube sizes. The first of which is 80 BT80 type tube, which is 66 millimeters in outside diameter, which barely fits the eggs. And then the other tube has to be some other dimension, and typically you're going to see BT70 type tubes, the original TARC BT70s that used to be used in previous years. And the motor sizes, ideally you want to pick motor classes that are in F range. In fact, that's the restriction, and a maximum of 80 Newton seconds total impulse. And then you want to pick the motors that are in the small end of that range in order to keep your costs down. The way to do that is you're going to put a mass balance in there, and right now I've got about 160 grams of extra ballast, and remove and add the mass necessary to meet your target altitudes. And this year, the target altitudes are going to be 254 meters for the initial rounds, and then an option of either 246 meters or 262 meters that's your target altitude on the final round. And then, again, the parachute has to come down and land it. Recommend at least a 24-inch parachute. That has to come down between 41 and 44 seconds for an ideal score. And your eggs have to be within certain dimensions of 55 to 61 grams, which is different than the original TARCs and the NRC National Competition eggs. And they need to be horizontally measured, no longer 45 millimeters in diameter, but they have to be a minimum between 56 and 59 millimeters in length. And that's, again, that horizontal restriction coming into play. So the strategy for doing that is to at first model your rocket as small as possible. The smallest tube dimension length is 6 inches. It has to be, one of the tubes has to be at least, both tubes have to be at least 6 inches long. So coupling an 18-inch tube with a smaller 220 or 250 millimeter tube and couple those together is what we've designed at the moment. And we've chosen the 29 millimeter engine mount motor size. You could go with all the 24 millimeter rocket motors as long as you understand that the limitation will be on your boosted total impulse. So we'll start out with modeling and simulating the 29 millimeter motors and then switch to the cheaper 24 millimeter motors if we can get all of the altitudes and masses that we need to live. That's really the only criteria. So it's a question of cost. If you go with a smaller motor tube, you tend to spend less money in total number of motors and get more launches that way if you have a limited budget.